the current situation, the current research done about Flash. Then we're going to talk a little bit about the problem that all current attack vectors share. We'll then introduce a technique we discovered that overcomes this problem. We'll show a real-world example demonstrating this technique. And then, if time permits, we're going to talk a little bit about testing Flash applications.
Okay, so before we continue, how many of you have Flash installed on their computers? Raise your hands. Okay, so that's great. So that matches Adobe statistics according to... Okay, so this matches Adobe statistics that says that over 99% of the Internet-enabled PCs are actually have Flash installed. This is more than Internet Explorer, actually. Flash was introduced by Macromedia a while ago, and it was then acquired by Adobe, which is promoting Flash technology in a lot of its development application. We see that in more advanced technologies such as Flex and Adobe Air, which makes use of the same action script, the same scripting language that Flash used. ActionScript, the first two versions of ActionScript were pretty similar one to another, while the third one, which Adobe has introduced, is more object-oriented and contains much more programmatic features.
The fact that Flash is so popular is because of mainly two reasons. One of them is because a lot of web developers tend to use Flash instead of other techniques like JavaScript or HTML, because a lot of web developers are more familiar with Flash and they feel more comfortable using that, even though they could use other technologies. And also, we tend to see a lot of Flash ads embedded inside web applications, and a lot of people are not aware of the security risks that those Flash ads pose. So we'll talk a little bit about basics of Flash. So there are actually two ways someone can actually access or place Flash applications inside his application. The first way to access Flash application is just embedding it inside an HTML page. This is done like this example here. And the Flash is actually just embedded inside the HTML page as an object.
What will actually happen is when the browser will render this, it will analyze the object tag, and it will actually contain a small part of the browser which will be hosted for the Flash player, and the Flash player will be in charge of everything that you will see there. So this is how it works, and this is one way to access Flash files by embedding them inside an HTML file. The second way to do that is by actually accessing them directly, so that when I browse to a specific URL of a Flash file, what will actually happen is that the entire Flash file will take the entire location with and height of the window of my browser. And this can be done in different ways. Some of the browsers, such as Firefox or Google Chrome, will actually automatically create an HTML file and have this embed tag with the source of the location of the file that you actually browse to. So this automatically generated HTML file will be the HTML that will be shown on your browser, but it will only contain the Flash file that you serve to. So this is an example. Okay.
Okay, so in order to understand Flash security, we need to also discuss another feature that Flash has. Now, as you mentioned before, Flash can contain a simple scripting language called ActionScript. Now, this scripting language, as other scripting languages, can contain global variables. Now, what's unique about ActionScript is that these global variables can actually be accessed and assigned from outside the movie. So this is an actually ActionScript piece of code. You can see the little icon there. We placed these icons throughout the presentation. So this is actually a very common use of these global Flash variables. The developer checks if this parameter is defined. In case it is undefined, it gets a default value. But if it is defined from outside the movie, it will actually get this value, and this value will be used throughout the code. And this is very useful for Flash developers to change the behavior of the Flash movie according to input assigned from the outside, from the HTML page.
Okay, so how do we assign global variables to the Flash? From the outside, we would like to pass this, the content, the values of these variables to the Flash itself. So we have 3 techniques to do that. The first one is by direct reference in the movie, and if we'll browse to the location of the SWF file and add a question mark and parameters in the format of the HTTP parameters, what will actually happen is that the Flash player will automatically define global variables called A and B with these specific values. And this way, the logic of the Flash file will be able to use those parameters.
The other 2 ways for assigning global values to global variables use the Flash file which is embedded inside the HTML page, not like in this example, which we browse to the Flash file directly. So the first one uses is pretty similar to the first one. Only the name of the movie now contains the URL format with the question mark and the variables separated by an ampersand. So these variables are also injected to the movie. And the third technique is called the Flash vars. This is when we use the Flash vars attribute that the object tag has, and we place the variables inside the Flash vars attribute, separated again by ampersand.
Okay, so a little bit about Flash security. There has been a lot of research throughout the past few years on Flash, and specifically there are some work done last year by Stefano Di Paolo, Italian researcher. And if you do not know them, it's the last 2 ones. We really recommend them, and just download them from the net. They're really interesting. Most of the research that has been done actually talked about what could you do if you were able to control these global variables. So, for example, if I'm able to control the global variable, I can perform a phishing attack. Let's assume that you have a website and a Flash file and with an item in it, and when you click it, your browser gets redirected to a specific URL. If an attacker will send you a link with the same Flash file, but will override the global variable that is being used inside this Flash file, you will actually be able to change the location where your browser is being redirected. Controlling global variables can actually change the content of the Flash file. It can perform flow manipulation attacks to actually change the entire code that is executed by the Flash player itself.
The two main attacks that can be triggered are cross-site flashing and cross-site scripting through Flash. These are actually two attacks that Stefano presented in his papers, and we're going to talk a little bit about them in the next slides. So the first one is cross-site flashing. This is what happens when a vulnerable Flash movie is tricked into actually loading a malicious Flash movie from a different domain, and this malicious Flash movie can receive access to the same sandbox as that movie. This is an example of a piece of ActionScript code which is vulnerable to cross-site flashing, and as you can see, the movie URI global variable is actually used inside a native Flash method, which actually takes uploads a Flash file and embeds it inside the browser.
Download.
Download, yeah. Sorry.
So what will happen if the user or an attacker will send you a link to this following URL? We see the movie SWF. This is the vulnerable Flash file containing this action script. And in the movie URI will actually put some malicious Flash file. What will actually happen is that the original Flash file will be shown in your browser, but that Flash file will be tricked to load the malicious Flash file. And that malicious Flash file will have access to the same content that appears in this Flash player, in the vulnerable Flash player. And that malicious Flash file will be able to change the content or to retrieve content out of it. In some cases, it will also be able to interact with the website that the vulnerable Flash is hosted on. So this is all the impact of this is very similar to the impact that we see in cross-site scripting all the time.
Okay, so the second attack that we're going to talk about is cross-site scripting through Flash. Now this is actually triggering a classic cross-site scripting attack by actually attacking the Flash file itself. And this can be done using several native Flash methods that can trigger JavaScript code. Okay. So this is actually an example of vulnerable code. As you can see here, the global variable URL is used inside the method called getURL, which actually is used to redirecting the browser to a different location. And when it is used here, we can actually trigger cross-site scripting. We're going to show you how. Let's first look at the normal usage of the application. This is actually a Flash movie that we've developed that shows 10 different Flash attacks, cross-site flashing and cross-site skipping through Flash attacks. Each button triggers a different, it's actually vulnerable to a different attack. Now, if you click on this button, the browser will be redirected to a different location.
And that is actually in the code, that is the default URL that is written in the code. So if we saw in the example before, that would be something like this. What will happen if the attacker will send you this attack vector? So as you can see here, the global variable is overwritten with this JavaScript piece of code, which contains an alert. And if we try to execute that, the alert will pop up. Okay? Questions so far?
Okay. In order to better present the problem that these attack vectors share, we need to talk about another thing that one more thing that we haven't discussed yet, and this is the fact that sometimes a Flash movie cannot be loaded when it's not embedded inside the original HTML page. Now this can happen because of various reasons. One is because Flash tends to interact with the DOM. And Flash might not be able to load because it needs some part of the DOM of the original HTML page and cannot load. Another reason is because of security. For example, the developer of the Flash movie can decide that it will not allow the Flash to load unless it is embedded inside the original HTML environment.
So if some Flash file actually interacts with the browser, when it will be loaded separately, it won't be able to execute some of its code. We can see an example for this in many websites, such as Google Finance. Here you can see an HTML page containing some HTML and JavaScript pieces of code, as well as a Flash file that appears here. And when I go and perform some actions on the Flash file itself, that actually changes the HTML that we see here. So every action on the Flash causes some pieces of JavaScript to get executed. And if those pieces of JavaScript were not existed in the embedded HTML, in the HTML that actually works as a parent for the Flash file, then this would not work. And the opposite can happen as well. I can press on some parts of the HTML, and as you can see, the Flash reflects those changes.
Okay, so this is what we want to talk about. So all known examples of Flash attacks that we have seen, that we have talked about, they all need to, as we said, manipulate global Flash variables. Now, all of them share one thing, is that they access the movie directly. They actually access the movie directly in order to inject these parameters into the Flash file. The attack vector would be that I, as an attacker, send you a link to the vulnerable Flash file together with the question mark and the injection of the global variable. This would be the way that I will attack you. But as we've seen, some Flash movies cannot load or are not embedded inside the original HTML environment. So this means that these movies can actually not be exploited. Even if they are vulnerable to some of the attacks we've talked about, the attack cannot be executed because the Flash will just not load when accessing directly. So actually, this is the technique that we have discovered and we want to talk about, Flash parameter injection, which is actually all about injecting these global variables into the Flash movie while it is still embedded inside the original HTML environment. Any questions? Okay.
Okay, so sorry.
You find some vulnerabilities in the Flash cookies in the Flash cookie?
We're going to discuss Flash cookies later on, and there is a technique that allows us to do that through Flash cookies as well. So we're going to show that. Okay, so the first example is relatively simple. We have here a server-side code that dynamically creates some HTML data. The location of the movie that will be loaded is actually submitted as an HTTP parameter. So what will happen in the regular use case is that the user will serve to this HTTP, or CGI, or any server-side script such as ASP, J2EE, JSP, and etc. And the content of the Flash file will be shown here. Now, as a simple attack would be that I would send the content of the regular Flash file, but I will also add the question mark and inject the global variable. So what will happen actually, that the HTML that will be generated out of this will be this HTML containing the global variable that I have passed. So what I'm doing is I'm passing the global variable to the HTML page, or the server-side code that creates the HTML page, and there is a vulnerability in that HTML page or server-side code that actually allows me to pass this global parameter through that, so that the Flash player will analyze this and see that there is a new global variable and he needs to define it.
Okay, another server-side attack is what we call piggybacking Flash vars, and this is the case where an HTML parameter is actually used inside the Flash vars attribute. For example, for this example, the language variable. So as you can see, the language was encoded in order to. Was encoded so that it won't be able to escape the quote sign. But what will happen if we actually use attack vector using the encoded version of ampersand? What will actually happen is that this will be decoded by the server and actually placed inside the generated HTML code. And what will happen here is that we got actually two global variables passed into the Flash movie. The first one is the language, which was intended by the developer of the application, and the second one is the global variables that we injected into the Flash movie.
So what happened is that the web server actually received one parameter, but when it embedded it into the Flash vars attributes, it actually created the ampersand sign here, and the Flash player thinks that there are actually two parameters now. Okay, so another technique is to actually inject the entire Flash var attribute. So in this example, we have the width that is being specified from the outside, and what we'll do here, we'll put the encoded version of single quote space and add the Flash var attribute. So when this gets executed on the server machine, the resulted HTML will be as follows. The framework actually decode this and put it here. So we see a new Flash var attribute appearing, and that Flash var will contain any global variables that we wanted. So all of these examples are showing you that we are capable of injecting the global variables to the Flash file, but still have the Flash file run in its original environment, in its original HTML.
Okay, Another example, and this is this time it's a client-side example, is what we call a DOM-based flash parameter injection. Is, for example, when the location of the page is actually used inside as a global flash variable. As we can see in this example, the location is actually used inside the flash vars created at the client side. So what we can do is send this tag vector, actually sending the hash pound sign after the location of the page, followed by an ampersand and the global variables we want to inject. Now what will actually happen here is that the location will be embedded inside the created HTML page, and we actually received two different variables. The first one is the actual location of the page, and the second one is the variable we injected into the Flash movie.
There's some nice thing to see about this. First of all, as you saw, the developer of this code used the encode URI method. So in some sense, he was aware of client-side problems such as DOM-based cross-site scripting, and the encode URI method actually protects you against DOM-based cross-site scripting here, because the encode URI method encodes the double quote sign so that any attacker cannot actually put anything here instead of in the location that will cause the HTML parser to get out of the context of this string. So we are not able to actually add new scripting to this. So we cannot perform a cross-site scripting attack here. But still, we are capable of doing flash parameter injection in the sense that we are capable of passing this information so that a new global variable will be defined on the flash file.
Another interesting thing to note about this attack is that because everything after the pound sign is not actually sent to the server, it's only used in the client side. This is actually invisible to any server-side system that is deployed. For example, an IPS or an IDS will not see anything wrong with any request which looks suspicious. So this is actually something that will be invisible to the server. What is really important to say about this example is that in this case, encode URI, which is a native JavaScript function, was not sufficient. And this is the function that is usually used in these cases in order to avoid the DOM-based cross-site scripting attacks. But it is not sufficient to actually protect against DOM-based flash parameter injection.
Okay, so the next example will talk about flash cookies, what this gentleman has asked before. So shared local flash objects are, as known as flash cookies, are used to save information on the client's machine. So this is very similar to HTTP cookies. And Flash allows you a very simple development process in actually storing such objects or retrieving those objects. And many Flash applications go on. Let's look at the following example. We have a code here that uses this Flash cookie, and it checks whether the Flash cookie is defined. If it is not defined, if it's the first time that the user has browsed to this site, then it sets the value of this Flash cookie to be the global variable. And at the end, either way, we go to and redirect the browser to the content of that Flash cookie. So what will actually happen here is that in the regular scenario, the Flash file will be able to put some cookies in your website, and the next time that you will surf to this website, the Flash cookie the Flash player will retrieve those Flash cookies. Now, persistent Flash parameter injection is a case where I, as a user, as an attacker, are capable to load the malicious or load the vulnerable Flash site in your browser and set malicious data within your Flash cookies. The next time that you will surf to the original Flash, then this malicious cookie will be used. And notice that what happens now is that this Flash file is embedded in its original environment. So still, the flow, everything will work, but it will use the malicious cookies that I've managed to insert before. Okay?
This can also,
So
So the cookies, the flash cookies are global for the flash. It's not for one domain or one path or anything.
There are flash cookies for each domain.
Okay.
So we can inject a flash cookie for a specific domain, and then the first time, if the attacker sends a link to the specific domain with the attack will stay inside the cookies in the repository of that domain, and every time the client actually serves to that domain, the value will be loaded in the flash and used. So this means that actually the attack persists.
So what you're worrying about is, so if this is being hosted on a different domain, it cannot actually add those malicious cookies because these cookies will be related to that different domain. What will you do in this sort of attack? That we need to find a vulnerability in the flash file that allows us to actually use the original flash file in order to upload this malicious data through the global variables, and then use the regular mechanism to load it. If you look at the example before, in this example, what we saw is that, as you can see here, let's assume that's what was happening. This is an initialization code. So every time this code gets executed, then there are some pieces of code here, and at the end, the victim or the browser get redirected to the location of the flash cookie. Now, as you can see here, I can cause, the first time that you browse to this website, I can cause you to use this new flash cookie that I sent you, because I can send you the flash cookie using the regular techniques of the problems that we see with global variables. So I send you a link to this vulnerable web page together with an injection of a global variable called input URL, and I'm putting my malicious content in it. So this time, when you execute the code, this malicious content gets stored in your flash cookies repository. Now, it doesn't matter if there is some code here that blocks from the attack being happening, because it doesn't matter really if the attack would work now or not. The only thing that matters is that I was able to inject this malicious cookie to your browser. Now, the next time that you will step to the site, to the regular site, to the index HTML site that has the object tag and contains the flash file in its original environment, that flash file will take the cookie, the flash cookie, and use it when it will try to redirect your browser. Was it clear?
Yeah, I think so.
All right.
Okay, so what's also important about this attack is that, as we said, it is persistent, meaning that after the first infection, the client remains vulnerable. Every time the client browses to that specific URL, the JavaScript code, for example, or the cross-site flashing attack will be executed. Also, because of that reason, the attack will be visible only to the server only in the first infection. After that, everything happens on the client side, so the server side is not alerted. It is invisible to the server. And also, what is important is that even if the flash movie is later on fixed, the attack can still persist unless the developer can take specific measures to fix this specific attack, meaning not using these flash cookies.
Okay, so let's talk about an example that makes use of some vulnerabilities we discovered in Adobe Presenter. Sorry. So Adobe Presenter is a desktop application that allows you to compile Flash files and HTML files, and together with that create a web page that is very nice, very similar, showing a lot of time it is used for demonstrations, and then you post this on your website and publish it to the world. So let's look. So this is a Adobe presentation. We didn't put any real slides here because we didn't have time to, but generally speaking, we have an HTML file, and that HTML file actually uses a JavaScript and a function called showFlash. Now, as you can see, this function is actually vulnerable to DOM-based cross-site scripting. This was actually found by Taviso Mandi from Google, and as you can see here, document.url is being used to create the string s, and at the end we have document.write_s, and as we all know, I hope you know, that a malicious user can send you a link with whatever payload he wants in the document.location. So let's try to do that. So putting the payload something like this, closing the object tag. Actually, you don't have to do that in most browser, and applying the script. And when the user will browse to this location, the script will get executed. So this is a regular DOM-based cross-site scripting attack. Now, the suggested solution for that was to use the encode URI method. And that actually protects you against DOM-based cross-site scripting. So if I'll save that, reload, you see that the attack doesn't happen. The script isn't getting executed. And the reason for that is that the encode URI actually encode the double quotes that I had to put in order to get out of the context of this value attribute. And I cannot get out of it, and I cannot inject my own scripts to that. So now we are safe against DOM-based cross-site scripting. Now, another thing that we have discovered is that the flash file that is being used here, viewer.swf, somewhere here, is actually vulnerable to cross-site scripting through Flash. So we found several global variables that if I would be able to control them, I would be able to execute a cross-site scripting through Flash attack. Now, if I would like to load the Flash movie in its original HTML, what I have to make sure that the user will actually browse to that original HTML, but still I need to make sure that those global variables that we are trying to inject will get injected to the embedded Flash file. So as you can see here, this is very similar to this is actually exactly the DOM-based Flash parameter injection technique that we talked about before. So what I would do is something like this, and then I need to, so this is the flash vars attribute. So I'm sorry, this is very similar to the flash vars piggybacking. So what I will do is I would have to put something here that ends the value of initial URL. So I'll put the ampersand sign, and that will tell the Flash player that a new global variable is starting. And then I will put my injection. This is underscore URL. This is one of them, underscore URL equals JavaScript and some JavaScript piece of code. So what will now happen is that on the client side, this piece of HTML code will be created, and the Flash player will actually identify two Flash variables. One is initial URL, and the other one is the underscore URL. And overwriting this will allow me to actually execute the cross-site scripting through Flash attack. So let's see, and it works. Questions so far? Yeah.
So I walked in, and this may be the first 5 minutes. So somewhere in here, there's a protection against this stuff, or are we completely open?
Yeah. So what you have to do as a developer, you must make sure that you're encoding user input correctly. And as we see here, it's not sufficient to just use encoding techniques. The encoding method should be applied according to the context of where the input value is being reflected. So in some cases it will be encode URI, in some other cases we should use other encoding techniques that encode other characters, such as the ampersand sign. Because the ampersand sign is not encoded, then the Flash player thinks that there is a new variable definition here. If it was encoded, it would understand that all of this is the value of the initial URL variable.
Okay. And as Flash developers and subject matter experts, what percentage of the community out there of Flash developers would know to get this right?
So what's funny is that a lot of time when we see Flash code, a lot of time it is being written by people who know nothing about security. We always see the copy-paste stuff. Yeah. So a lot of time we see code that user make use of global variables while they don't really need to do that. So they use the template that we've shown you before. If variable is undefined, then define it. But actually there is no sense in doing that because they always want to use the same value. So they should have just statically defined this variable saying initial URL equals whatever they want. And by doing the copy-paste thing, they are creating more security threats into their own applications. So we mostly see that security is not a real consideration in many of the developers.
There are some attacks that were published, some of the attacks that we've talked about were published back in 2002, and we still see the same exact pieces of code in applications today. Attacks that were publicized for a very long time.
And we see that a lot of vendors put Flash ads into their websites. We've all seen that, right? And what needs to be remembered is that adding this Flash file into your website might pose more security threats. So you have to take that into consideration when you do that. So it's not just, let's take someone's Flash, it's someone else wrote it, I don't know. When you put it on your website, then it poses security vulnerabilities to your own website.
To your own client. So in this case of the Adobe Presenter, what actually needs to be done is not only download the fix presented by Adobe and installing it, you also need to recompile your entire Flash movies. Because Adobe Presenters actually creates Flash movies, and all the Flash movies created by Adobe Presenter were vulnerable to these attacks, and this means that you actually need to recompile your entire Flash applications and deploy it on your web applications. Okay.
Okay, we can go.
Okay, so we'll talk a little bit about testing Flash applications. Just say a few words about it. So the first thing you need to do when testing Flash application is to identify those global Flash variables we've talked about. And there are actually several methods that are stated here on how you can do it, and we'll gladly discuss it. But because we are actually running out of time, we actually just say a few words. We want to discover these global Flash parameters. We want to discover where they are being used inside dangerous native functions, and we want to actually link the entire sequence of actions that the user has to do in the Flash in order to get to that vulnerable code. Meaning if the user has to click several buttons or navigate between several frames, we actually want to remember the sequence leading to that vulnerable code. We then want to inject the values to these global parameters, and then we want to navigate to the location of the vulnerable code and actually test to see if the code was executed, for example, if the JavaScript code was executed, or if a malicious Flash file was loaded, or if the code flow was changed. But what we do want you to remember about testing Flash applications is that you actually have to test Flash applications within the original HTML environment and not just test the Flash as a standalone file. That is because of this of the Flash parameter injection, that sometimes the Flash will behave differently if it is not if it is accessed directly, not inside the original HTML environment, and you will miss some vulnerabilities in your Flash movie if you will test it as a standalone Flash movie. Yeah.
Since Flash movies are compiled intermediary code, is there would be a better solution to decompile the code and then just test it from there? That way it can do all possible use cases.
So you're talking about looking at the code itself and try to understand that. Yeah, so there are two techniques, general techniques into identifying issues, one by executing the code and one by looking at that and maybe doing both of them, I don't know. And you can do both. And what is important is that you will eventually have to understand all of the stuff that we talked about here. So you have to be able to know whether a mutation of the global variable will be able to access a potentially dangerous method. So any technique is good for that.
More question? Yeah.
I use IBM's tool AppScan, and I wonder if you're familiar with whether or not AppScan does check for this.
So presentations in Owasp are vendor free, so we rather not talk about products. If you want, you can come to us later and we'll be happy to discuss. Sorry. Yeah.
Not talking from any vendor, are there some code review products that that are that work to scan Flash files?
So about specific products, come to us. We'll be happy to help you with this. We really try in Owasp to keep the lectures vendor free and not do any marketing or anything in the lectures. Okay.
So your answer is yes. There are some.
Come to me and we'll talk about it. I'm trying to be really decent.
There are any more?
So, any questions? Any more?
Now, can Flash movie has access to your local workstation, right? What's the trust between a Flash movie in the browser and your file system, for example? Is there
So generally speaking, Flash movie code will not be able to access your local files, for example, unless you specifically permit that. So you're safe from that. What it will be able to access is it will be able to send and receive requests out of the domain that it is hosted on. So for example, if there are some sensitive information in one host and that host contains a vulnerable Flash file, an attacker could inject pieces of code to that vulnerable Flash file either by cross-site flashing or cross-site scripting through Flash, and this malicious code will be able to interact with the sensitive website, and if it's a bank site, and perform transactions or see recent transactions value and all the stuff that we see all the time over the web.
The second question I have, how capable is ActionScript? Can you do like HTTP requests to a third-party domain, whatever, from the actual Flash?
There are options to do that. There are some restrictions. Generally speaking, if the other domain allows you to do that, you can easily do that using. You need to configure that specifically. And you can also send blind requests. Just send requests everywhere you want, but you won't be able to see the responses of those. This is for security.
Actually, what Adobe did is they made certain ways that you can actually bypass the same origin policy inside Flash movies. So actually Flash is a little bit more, or could be a little bit more vulnerable to the bypassing of the same origin policy than regular JavaScript and HTML.
Okay, thank you.
Thank you.
Hey, how are you? Yeah, so we are doing that. We've been working that for a while, and we in the next version of AppScan we are introducing Flash execution techniques. So we both are capable of doing crawling on a Flash application as well